If we plug in 0, then we're going to get the square root of 49, which is 7, minus 7 is 0 over 0. So if we cheat and plug in, we get 0 over 0, which tells us to try something else. And generally, if you have a square root plus or minus something, then you do the algebraic conjugate, which means take what you started with, the square root of 5x plus 49 minus 7. And in the bottom, we have 3x. And what we're going to do is we're going to multiply top and bottom by the conjugate of the numerator, which is the square root of 5x plus 49 plus 7. And then hopefully something magic happens. So I have to do the same thing in the bottom. Okay, so the point of multiplying by the conjugate is that implies, so we have a plus b times a minus b, which always evaluates to a squared minus b squared. The middle terms disappear, and my a here is a square root, so that means I get to get rid of the square root in the top and see what happens. So that means here, switch color, I get my a squared, so the square of the square root is 5x plus 49, minus the square of 7, which is 49, all divided by 3x times, I'm not going to bother distributing in the bottom, 5x plus 49 plus 7. And here you can see something magic does happen in the top. I have 49 minus 49, which is 0. 0 plus 5x is 5x. So that's my new numerator. And because the denominator 3x is connected by multiplication, these x's right here divide out and become a 1. So this whole thing simplifies to 5 in the numerator over 3 times the square root of 5x plus 49. Oh boy, that's getting a little tight there, plus 7. So this limit right here is now equal to the limit as x approaches 0 of 5 over 3 times that square root plus 7. And now I can try and cheat and see what happens. Well, the numerator is just going to be 5, and the denominator is going to be 3 times. We're cheating with that 0 there. 5 times 0 is 0, plus 49 is 49. Square root of 49 is 7. 7 plus 7 is 14. And let's see, what's 3 times 14? 30 and 12 is 42. So this should be 5/42 in the limit. How could we check that? We could look at the graph of this sucker right here and see what the y value looks like when x is close to 0. And what we're going to find is at 0, it's undefined. But if we approach from the left to the right, we should be getting pretty darn close to 5/42. And here we used the conjugate of that square root expression in the top for our algebraic trickery.